Hey everyone, welcome to the channel. My name's Nader. In this video, we're going to go over some problem sets or exercises for arrays. We're going to do this for the basic array functionalities that we looked at in the previous video, mainly things like push and pop, as well as shift and unshift and how they work with arrays and just kind of array syntax in general. If you'd like more practice, I highly encourage you to go through all the examples in this video with me. Let's get right into it. Alright, so as in the previous exercise videos, I have a bunch of files already kind of ready with a bunch of comments. What I'll do is I'll go through the comments real quick, just verbally, and then I'll give you a chance to try it out, and then we'll code it out together. So this is the warm-up. For the warm-up, we are asked to create an array with the following strings. So 4 strings, Mercury, Venus, Earth, and Mars. You can tell that I love space. And then the second step is to add the string Jupiter to the end of the array. Then the third step is to add the string Sun to the start of the array. Step 4, we want to remove the last 2 strings from the array, and then step 5, we want to remove the first 2 strings from the array. And then after each of these steps, we want to print the array out just to see kind of what these manipulations on this array look like when it gets printed out. So I'll give you a moment to try that out yourself, and then we'll go through it together. Okay, perfect. So step 1, let's create an array with these 4 planets. So I'll call it const planets, and I'm going to have Mercury, have Venus, have Earth. You can tell it takes a really long time to actually code these out, but I'd like you to see me do it with you. So that's step 1, and we're asked to print it out after each step. So I'm going to console log out planets. Perfect. Step 2, we're asked to add the string Jupiter to the end of the array. So that means after Mars. So we want to have the kind of array have Mercury, Venus, Earth, Mars, and then Jupiter. So how do we do that? We learned in the previous video that to add something to the end of an array, you use push in JavaScript. So we're going to use the array that we want to add something to, in this case planets. We're going to call the push method on it, which is very similar to a function. And this takes the thing that we want to add to the end of the array. In this case, we want to add the string Jupiter. And we want to console log out planets as we go. What I'll do is I'll just open up my terminal and start logging this out just so we can see that we're on the right track. I highly encourage you to kind of do this as you're doing these just to make sure you're on the right track, because sometimes you might have an error or you write a whole bunch of codes and it does the wrong thing. So it's better to catch those as early as you can. So I'm going to run node and then exercise warmup. And it looks like it's working. I have my 4 planets here, and then I pushed Jupiter onto the end right here. And now we have 5 planets in our planets array. Perfect. So the next thing we want to do, step 3, is add the string Sun, but we want to add it to the start of the array. So it's a little bit funky, definitely less used, but good to get practice with. In the previous video, we learned that to add something to the start of the array, we use the shift method. The unshift method. You can see I always confuse these all the time. To be completely honest, I usually have to look these up. I always mix up which is with, because these are definitely less used than push and pop. So I want to unshift, which means add something to the start and moved everything over, Sun, which is the first planet star in our solar system. And then we want to console log out planets. Perfect. Let's make sure that works. I'm going to rerun this code, and indeed we get Sun at the very start here, which is the 3rd console log that's being printed out. Fantastic. Step 4, we want to remove the last 2 strings from the array. So to remove things from the end of the array, in this case the last 2 strings, we learned that we need to use the pop method. So I'm going to use planets.pop, and I'm going to do this 2 times. All right. So I'm just going to clear this out, and I'm going to make sure to console log out my planets array after I do the 2 pops. Run this again, and indeed we saw that Mars and Jupiter get removed, and we're back kind of to the starting array that we have over here, almost, except with almost the starting. We have the Sun at the start, and then Mars was removed from the end. compared to the starting one. So let's do the reverse now, which is step 5, which is to remove the first 2 strings from the array. So in this case, we want to remove Sun and Mercury. So previously we removed Jupiter and Mars and Jupiter. This is getting confusing. There's a lot of prints on the screen. We removed Mars and Jupiter with the 2 pops. So the first pop removed Jupiter, the second pop removed Mars, and we're left with this array. Now what we want to do is kind of the reverse. We want to remove Sun, and then we want to remove Mercury, and we should be left with Venus and Earth. So to remove something from the start, it's the opposite of unshift, which is shift. This is the one I say I always get confused with. And this doesn't need to take any arguments because it just removes it from the beginning and it removes 1 item. So we're going to do that, and we're going to print it out just to make sure we have the right results. And I'm going to run this one more time, and we can see that indeed we have Venus and Earth left. So just to recap this, we have all the planets, then we pushed Jupiter onto the end, then we pushed Sun into the beginning using unshift. Then we removed the last 2 planets, which were Mars and Jupiter, using pop. Then we removed the first 2 planets using shift, which were Sun and Mercury, and then that left us with Venus and Earth. Perfect. So let's go to the first exercise. That was just the warm-up. Okay. So for this one, we're asked to create a variable called multiple, and we want to initialize it to 5. Interesting. Then we want to create an array with the numbers 10 to 15 inclusive. Okay, we can do that. Then we want to loop through the array, and on each iteration we want to kind of do these things. So we want to first multiply the number by the multiple and print out the result. So I'm assuming that means 10 times 5, then 11 times 5, kind of like we have here, all the way to 15 times 5. And the bonus here is to see if we can make it work so that if we just change multiple, it'll work for everything. I just noticed that I messed up my steps here. It's actually 1, 2, 3. So give that a shot, see if you can get that working, and then we'll regroup together and code it out together. Okay, so create a variable called multiple. So I don't know if I'm going to change this yet. I'm just going to do a const for this. I'll call it multiple. And we're saying initialize it to 5. Okay, great. Step 2, we want to create an array with the numbers 10 to 15 inclusive. So I'm going to say, let's just call this numbers. And this is going to be 10, 11, 12, 13, 14, and 15. Just like that. Perfect. Step 3, we want to loop through the array, and on each iteration we want to multiply the number by the multiple and print out the result. And then we want to kind of show it like this. Okay, so let's see how we can do this. So we know that in order to loop through an array, we can use the array indices. So we can do this using both a while loop technically, but a for loop might be a bit easier since all the things that we need for that are kind of inside of the for loop construct. So I'm just going to create a for loop. I'm going to say let I equal 0, which is going to be our index, starting at index 0, which is going to be the number 10 in this case for the numbers array. And I'm going to say while the index is less than, and I want to make sure that I don't hard code the value for the amount of times we want to loop. I want to actually loop for every single element in numbers. So maybe in the future, if I add more numbers to this array or remove items from numbers, it'll still work. So we learned that the numbers has a .length property on it that will dynamically get us the length of numbers, which is an array. So while I is less than numbers.length. Be careful not to do less than or equal to, because if you actually count from 0, you're actually going to overstep the bound or the end of the array when you're looping. Next, we want to make sure that we're increasing I by 1 each time so that we're actually stepping through this array 1 index at a time. All right, so let's think about this. We want to print something like this out to the screen. But first we're asked to multiply the number by the multiple and print out the result. So let's just say const result is equal to the number multiplied by the multiple. So the multiple is 5, and the number in this case is going to be from 10, 11, 12, 13, 14, 15. So we can just say multiple multiplied by, so how do we get the item at that index in the array? Because we want to actually the number 10, the number 11, number 12. we can do array indexing to grab that value out of numbers. So if I do numbers and then square brackets and then I, this will dynamically get me the numbers inside of this array, or the items inside this array if they weren't numbers even. Okay, so this is saying numbers at 0, numbers at 1, 2, 3, 4, all the way up until the last element in the array. So in this case, it's going to be 0, 1, 2, 3, 4, and 5 indices. Okay, so I have the result. So this is going to be 10 times 5, 11 times 5, etc. Let's just make sure this works. So I'm going to go with my advice and actually log this out and make sure this actually works, to make sure that our code doesn't have any bugs in it. I'm just going to pull up my terminal, clear this out. I'm going to run node, and this is exercise 1. And great, it looks like we're actually getting the result, which is super awesome, right? But we're asked kind of to do this extra thing, which is like, can we actually log out what this looks like when we're doing the multiplication as if it's kind of doing the math for us behind the scenes? So how can we go about doing that? Well, we can use template strings to make this a bit easier on us, and template strings allow us to interpolate kind of variables inside the string. So I'm going to get rid of this result here, and I'm going to show you what I mean. I'm going to use these angle quotes, which is a template string, and I can put variables inside here as long as those variables are inside the $ and the curly brackets. So I want to be able to say 10 times 5 equals 50, 11 times 5 equals 55, right? So this part is changing. This part is always the same, that's multiple, and then this part's always changing, but we have all these values. So the 10 in this case is numbers at I, right? Because every single time we're going to go up by 1. We're going to go 10, 11, 12. So I'm going to grab numbers at I. I'm going to put that right here. Then I'm saying multiplied by, and then we want to have 5. This doesn't change. It's always multiple. Oops, this is definitely a $sign. Multiple. And then an equal sign, and then we can put another $sign and curly brackets here, and then now we can inject into this string the 50, 55, 60, etc. all the way to 75. And that is our result, which we already calculated. If we really wanted to, we can actually put this calculation directly in here and not even have this line that's an intermediary line. But let's see what this looks like. So if I run this, we'll see that I actually get the right answer, which is what we were looking for, right? We get 10 times 5 is 50, 11 times 5 is 55, etc. Now the bonus, I realize is actually kind of built into this, because step 1 technically allows us to do this. And I want to show you what I actually mean by this. Imagine that we didn't have multiple for a second, right? And we only had this code here, and we just wanted to know that it was 5 every single time. If we didn't have multiple, we would have had to hard code 5 here and 5 here, and then it would work, right? So if I clear this out and I do this, we still get the same answer. But now if I want to change what that multiple is, I have to look through the code and change it in multiple places, and I might make a mistake. So in this case, I'd have to change it here, and I would have to change it here. But notice what happens if I actually use a variable in its place instead, and I uncomment this and comment it back in, right? Now, if I want to change multiple to say 10, I just have to change it in this one spot. And check this out, if I run this code, it's actually going to update to reflect the correct calculations. And I only have to change that in one place. So definitely look for places in your code where you can kind of start to practice these kinds of optimizations. It's not the end of the world if you don't do this. What you'll notice though is that you're going to end up changing a lot more code in a lot more places, and maybe even have some bugs as a result of not changing it in every single spot. If you're using something in multiple places, ask yourself if it makes sense to create a variable that you can refer to instead of hard coding it in all those spots. And similarly, I'd like to show you that with numbers array right here. Like I said before, since we're using the length right here, I can actually add values to this. I can add 16 and 17, for example. And if I clear this out and rerun this, you can see that it still works, right? I still get the correct answer, which is also quite remarkable, right? So this code that we have right here is actually pretty versatile, right? We have, as long as we have this multiple, and we changing this numbers, it actually works perfectly, right? And we'll see later how we can kind of optimize this even further by using things like functions. But for now, this is definitely pretty much optimal code, at least as optimal as I can think of while teaching this to start. Perfect. Let's go to exercise 3. So for this one, we want to create a variable called greeting, which is a string, and we want to initialize it to hello, nice to meet you. Okay. And then we want to use a loop to loop through this string. That was really hard to say, just like you would an array. Okay, so we're looping through a string. We haven't seen this before, and that's kind of the point of this exercise. I want to kind of mention how this works. And on each loop iteration, we want to print out what is at that index. Okay, so I want you to create this string and then pretend it's an array and try to loop through it just like you would an array and print out what is at that index if you're using each index one time per loop and see what you get. I'll give you a moment to try that out and we'll try it out together. Okay, so once you've tried that, let's see what this looks like. So we're going to say const greeting is equal to, and then I'll just actually copy this so I don't have to accidentally make some typos. Hello, nice to meet you. Perfect. So then we're saying that we can use a loop to loop through this string just like you would an array. Okay, so if I create a for loop and I do my same thing, I have my index which starts at 0, and I'm going to say while I is less than what? Well, if I want to believe what I have on line 5, then maybe greeting has a length. If it's like an array, let's try that. I'll say greeting.length, okay? And I++, we'll just go up by 1 every single time. Then it's saying on each loop, print out what is at that index inside of greeting. So if I do a console.log and I grab greeting at that index, so greeting at index I, so greeting at 0, 1, 2, 3, all the way to the length -1. Is this gonna work? Right? Let's try it out. So if I run node and exercise 2, oh my goodness, it actually does something, right? So I'd like you to try to think, why does this happen, right? And what might this look like inside the computer's memory if you think back to the videos on arrays and even variables and kind of their implementation inside the boxes or that table inside the computer's memory. Okay, so once you give that a thought, I want to just kind of go back to this drawing here, which I had from the previous video on arrays. And I showed you that when we have an array like this, which is an array of strings, it looks like this inside of the memory representation, right? So we have one string kind of per slot in our computer memory. What's interesting is that when we have a string, you can think of each of these slots as just being one of those characters inside of the string. So if we had the string monkey, for example, this would be M, O, N, K, E, and Y. And we would have indexes or indices 0, 1, 2, 3, 4, and 5, respectively. Or 6, that should be 6, or 5. So you see, off by 1 every single time when I start at 0. Always happens. So we'd have indices 0, 1, 2, 3, 4, and 5 for monkey, if it was just the string monkey and not the array. So inside the computer's memory, it's very, very similar to an array. There are some differences, but we can actually treat it like an array just like this. In fact, in many other languages, this is explicitly how you actually would code it out, and this is how it works. So we can technically say that a string is an array of individual characters. So for example, if we had the string hello, the string hello would look like this. It would be H, and then E, and then the 2 L's. This is really hard to type quickly. And then the O, right, for just this part. And you can imagine how if we were to loop through this, we would get this right here, H-E-L-L-O, all on different lines. right? So that's how strings work behind the scenes inside the computer. Definitely a useful thing to keep in mind. Also, this length property is part of a string. There are things that do not work on strings that do work on arrays. For example, we can't do like a greeting.push. There's no push that we can do on a string. It only works on arrays. However, things like length exist, and we can index into the string. So it's an array-like object, but not explicitly an array. All right, perfect. If you have more questions about that, I highly encourage you to ask them in the comments, and I'll do my best to help explain as best I can. Let's go to exercise 3. Perfect. So for this one, we want to start with a variable called total that starts at 0. Then we want to create an array called grades that has these 6 numbers in it. Okay. Hopefully, maybe this is a good grades or bad grades. I'm not actually sure. It depends on what the scale is and kind of what classes you have. I'm pretty sure I definitely didn't do this well in school for a lot of my classes. Probably saw a lot of ones that were lower, believe it or not. And I would love to see grades like 98 or 91 if it's out of 100. That'd be great. I hope some of you have had a chance to get some higher grades, but really it doesn't matter too much at the end of the day. I have had a lot of grades like this. Enough of a tangent there, though. The purpose of this program is to find the average grade. So keep in mind that the average of a group of numbers is the sum of all of the numbers divided by the number of numbers. Okay, so in this case we have 6 numbers, right? 1, 2, 3, 4, 5, 6. We would want to add them all together and then divide that total by 6 in this case. Okay, I'll give you a moment to try it out yourself, and then we'll go through it together just like the others. Okay, perfect. So a variable called total, and we want to start it at 0. So my fingers want to type const here, so I would say const total equals 0. But we're actually going to change this, and I'll leave it as const, and I'll change it later, and you'll see why. We want to also create an array called grades. So I'll say const grades is equal to, and this has got 55, 63, 82, 98, 91, the really good grades, I guess, and then 43, which is more like what I got. And we want to figure out how to print out the average grade from all of these. So the average grade, so we have to add these all up together, and we need to divide it by the total number of grades in this list, which is 6. So that probably means that we want to go through each item one at a time and then kind of use something to keep track of adding them all together. So let's create a loop. So I'm going to say for let I equals 0, hopefully your fingers are used to typing this out by now. I'm going to say I is less than grades.length. I'm going to use the length property on grades to make this dynamic, just like the previous one. And then I'm going to say I++, just to loop one at a time through the grade indices. So each item that we're going to look at is actually grades at index I. So we want to do something with that value. So 55, 63, 82, all the way to 43. What do we want to do with it? Well, we have this total variable, and we want to keep adding to this total variable since it starts at 0, what each of these grades are. So we want to add 55, then 63, then 82, all the way up to 43. So this is going to be a pretty big number by the end. So how do we do that? Well, we want to say total, and then we want to say plus equals, and then grades at I. So we're going to take 55 added to total, 63 added to total. Just if you haven't seen this before, this is the same as total. It's equal to total plus grades at I. Okay, and then I want to just console log out the total and see what happens. If you've been paying attention, you might notice that I'll get a nice glaring error here. Oh my goodness, what is happening? So as I mentioned, we created total as a const variable, right? So I usually try to default to const for most variables, but in this case, it kind of backfired and kind of bit us. And that's because we're trying to reassign total to a new value here on line 20 in my case. We're actually updating it or manipulating it, and you're not allowed to reassign something to a const variable. So I need to change this to a let variable in order for this to work so that we can actually change it. Let me try this again. And look at that. We get the total sum of the grades. So this is not quite the answer because we want the average. The average, as I mentioned, is this divided by the number of grades. So if I console log out total divided by 6, because that's the number of grades I have, let's see what we get. We get 72, right? I guess that's not a bad average. I'm not actually sure. But this looks pretty good. So that's definitely the right answer. But how can we improve this code here on line 24? I'll give you a second to think about it. So as I mentioned a couple of times, anytime you see numbers like this kind of laying around, you want to be careful and try to think of, can I use like a variable or something else in this place so that I don't cause any issues? And I'll show you where this becomes a problem. Imagine that I added a new grade here. Let's say I got 100% on something, right? Let's try to run this code and see what happens. Okay, so I get this, which is the correct answer. So 432 plus 100 is 532. But my average went from 72 to 88.66666. Is that right? Trying to think if that's right or not. So what you might have noticed is I have a little bug in my code. I hard-coded this 6 here instead of actually using the length of the grades list. So if I grab the length of the grades list here for calculating the average, and I rerun this and I use that length instead, you'll see that my average now only goes up to 76, which is actually the correct answer, right? So I got the incorrect answer if I'm kind of a bit sloppy or not careful with how these variables are, if I hard code things and forget to change them out later. This, you can imagine, gets exacerbated with when we have just huge code bases or multiple files with variables in them, or just very, very, very long files. You can imagine you'll forget to change it in every single spot. So definitely try to use the dynamic version of things or variables in places where you can. Perfect. Let's go to the bonus. I couldn't resist myself, had to make a bonus for this one, so let's take a look. Okay. So for the bonus, we're going to create a variable called bakery, and that points to an array. And we want to fill the array with a bunch of strings. I hope you're not hungry. We're going to fill it with cake, cookie, bread, and scone. So 4 different strings. Then we want to print out bakery to make sure it has these strings in it. That seems okay. Then we want to create another variable called myBakery and assign it to bakery that we declared previously. Interesting, curious. Okay. And once we've done that, we want to add croissant and granola to myBakery. Then we want to print out these 2 arrays and see what we get. Okay, this doesn't seem too bad. Let's try it out. Give you a moment to try it yourself and see the results and kind of ask yourself kind of the why question. See if you can piece together why the behavior that you're seeing is happening, and then we'll go through it together. Okay, so for this I'm going to create a const, and I'm going to call it bakery as they asked. And I'm going to put in cake, cookie. I actually am a little bit hungry as I'm coding this, so this doesn't really help. Bread and scone. Perfect. And then we want to print out bakery. So let's console log bakery. Let me just bring up my console just to make sure that we're on the right track here. Always good to run this bonus. Perfect. Nothing too fancy there. So we have an array of strings and we printed it out. So we're done this. Now we want to create another variable called myBakery and assign it to bakery that we just declared. Okay. So I'm going to create another variable, myBakery. They didn't say const or let, so I'm just going to go with const, and I'll assign it to bakery. Okay. Then I want to add to myBakery croissant and granola. So I'm going to say myBakery.push, which adds it to the end, and I'm going to say croissant, and I'm going to also add granola. Then I want to print out myBakery and bakery. Okay, so I'm going to console.log. I'm just going to do a little bit extra here just so that we can kind of see how this works. I'm going to say bakery, and I'm going to put bakery, and I'm gonna put console.log my bakery and my bakery. And I'll run this. And what we'll see is, this is why I kind of put the labels, just so it's slightly less confusing. At the start, so this line 24 right here, where we're console logging out bakery, we have cake, cookie, bread, and scone, which is perfect. That's what we expect. Then we're saying create another variable called my bakery that points at bakery, or points at what bakery points to. Maybe. Let's see. Then we're saying push croissants and push granola to my bakery, not bakery. So the weird thing here is if we look at bakery, bakery had the items pushed to it, and so did my bakery. So it kind of looks like bakery and my bakery are the same? Question mark? Right? What do you think? Are they the same? Are they different? Are they copies of each other? Give that a thought, and then we'll see the answer in a sec. So it turns out that unlike primitive types, which we looked at in a previous video in JavaScript, arrays are not primitive types. They are not creating copies for every single assignment. The arrays that bakery and my bakery are pointing at are the exact same array in memory. They are just both labels pointing to the same memory location, the same array in memory. So when we change one, we are changing the other. And this is true of arrays and a couple of other things that we'll see later on. So if you think to this picture, if I created like animals 2, for example, and I said animals 2 equals to animals, then both of animals and animals 2 would be pointing to this array right here, the same array, right? With the same indices and the same values. The reason for this is that these arrays can get quite large and take up a lot of space in memory. In order to make JavaScript fast and efficient, and this happens in every single programming language, unless we tell it explicitly not to, is that we reuse that memory space. Imagine if you have millions of these strings inside an array, and you do something like this, where you create another variable to point at that array. It would be terribly inefficient to create a duplicate of that million string array or million number array and then just point at that duplicate, right? We can explicitly do that using other methods, which we'll see in future videos, but the default behavior is to not do that. The default behavior is to point to the same array. So changing my bakery is the same as changing bakery, and vice versa. Changing bakery is the same as changing my bakery. And if I created more variables that point to my bakery or bakery, they would all be pointing to and changing the exact same array. The same array of these 1, 2, 3, 4, 5, 6 wonderful bakery items in it. This is to save memory, and it makes JavaScript much faster. Okay? So I hope you enjoyed this video. If you found this useful and some of these challenging, I'd love to hear in the comments as well. If you could like the video and subscribe to the channel, that would be great. If you do want more exercises or practice, definitely let me know in the comments as well, and I'll try to come up with some more to kind of tease all of you. Also, I'd love to see kind of your solutions. The ones that I came up with here are definitely not the only way to do these things. There are almost an infinite way to do these different concepts, especially as we get to the more complicated concepts later on in future videos. I'm just showing kind of what I think is the most obvious concept, at least to me, to start, or what I would expect someone who's just starting JavaScript to do, but by no means is it the only way to do these things. In the next videos, what we're going to do is actually look at some of my favorite functions using arrays, and those are map, filter, and reduce. And just like I said now, where we're pointing to the same copy of the array in memory, these are actually functions using a programming style called functional programming that allow us to actually create copies of these arrays at will if we want to create a copy. And doing that allows us some very powerful behavior, which we'll see in those videos. I'm also going to create an exercise set for each of those videos as well, just so we can get even more practice. I can't wait to get to those videos. I'll see you there.